Good afternoon, everyone. My name is Don Parkinson, and I'm a consultation specialist with Atkins Realis. Today, we are continuing our series of live stream topics as our project moves through or moves into consultation round 3 of the environmental assessment phase. The topics we are covering parallel our project activities or are of community importance. So we hope these will help our viewers and listeners better understand the project and provide input along the way. With me today, as usual, is my co-host, Jennifer Ashwazage Pereira, my colleague and an Indigenous engagement and traditional knowledge specialist at Atkins Realis. It's a long job title, Jen.
It
You need
sure
to put an
is.
acronym on that. You need to put an acronym. Put it again. Come up with an acronym on that. A clever acronym for that. Um, Jennifer is a member of Henvey Inlet First Nation, located on the beautiful French River south of Sudbury, and works with me on our projects across Canada. And Jen, I was going to tell you, I was just reading before this that TVO has done a documentary on the French River. I don't know if you've heard about this,
Oh,
but
I
it's
have not.
airing very soon. I'll send you the details that I found. It's airing very soon, and basically, it involves traveling, I think 110, I don't know if that's the full length of the French River. I don't know enough about it, but it's a 110-kilometer canoe journey along the French River, and it's basically just recording. Obviously, it's edited version because it's been edited into a couple of hours or 3 hours, but because that would take a long time, obviously. But just recording, like it's very little narration, very little, you know, speaking whatsoever, just recording everything, like the sounds and sights of the French River as they paddle down the French River, I guess, to the mouth, which is really
Oh,
kind of interesting. So anyway, I'll find out the info on it. It's going to be on TVO, so I thought I'd mention that
yeah, that
to
was one of our
you.
major highways, and there's a lot of pictographs on the rocks around there.
Yeah, yeah, and I've seen similar documentaries. I saw one on the Ottawa River where it's kind of nice actually. It's very peaceful because you just watch as this boat or canoe or whatever moves along the river and then ends up in Ottawa, right?
Okay, kind of like the
It was really,
Netflix fire at Christmas time with the crackling logs by
yeah,
the river.
yeah, exactly. Yeah, but it's very relaxing, right? Because you just hear the birds in the background and the wildlife, and anyway, beautiful scenes. So let's get started, Jen.
Okay.
Quite, quite a bit to cover today. We're going to talk about geology, terrain, and soils and the preliminary findings uh,
Hmm.
from our work on that. And I'll do a quick run through the topics. We're going to do, as usual, a project background. We're going to talk about geology and geochemistry. We're going to talk about geological hazards. Then we're going to talk about physiography, which is like the physical geography of the study area, soils and permafrost, and then we're going to talk about how you can get in touch with us. So, without further ado, let's talk about where this project is located. So, the project location is Northern Ontario, about 600 kilometers north of Thunder Bay. And Webequie First Nation is about 200 to 250 kilometers from both Hudson Bay and James Bay. And the planned road extends from the airport in Webequie First Nation southeast to just east of the Muckatai River in the McFalds Lake area in the heart of the Ring of Fire. And in terms of the purposes of the Webequie Supply Road, it's to move materials, supplies, and people from the airport to the McFalds Lake area. Another purpose is to provide employment and economic development opportunities to Webequie while allowing them to both preserve and enhance their language and culture and continue to live in their community as well. And then finally, to provide experience and training opportunities for youth to encourage them to pursue higher education, post secondary education, or other training. In terms of the project itself, it is again a planned 107-kilometer long road extending from uh, the airport to the McFalls Lake area. Of those 107 kilometers, 17 sit on the Webequie First Nation reserve lands. The preliminary preferred corridor that we are working with basically is our planning corridor, and that is so the road will actually end up being positioned somewhere within that 2 kilometer wide band of land and water extending from Webequie to the Ring of Fire area. And the final corridor width will be, so the right of way for the road will be 35 meters. Now, in terms of other information about the project, okay, let me bring this up. There will be 3 major water body crossings. Um, the first being of Winnisk Lake, which is about 200 to 250 meter wide span. The second is Winniskissis Channel, which is southeast of Webequie, which is about 30 to 40 meters in width. And then the final one is the crossing of the Mukatai River, which is about, again, 30 to 40 meters in width. And that takes you to near the eastern end of the Webequie Supply Road. And as with most road projects, it includes the road is not, it's more than just a road. So it's more than just the 2-lane gravel road. It includes both temporary and permanent aggregate pit and rock quarry areas, um, as well as the access roads to get to these areas, and any crossing structures, water crossing structures that are required to cross water bodies or water courses in order to get to those aggregate pits and quarries. There will also be construction camps. There's planned to be 4 construction camps. These would be temporary, and obviously the idea is that these would accommodate the construction crews, and there would be operations and maintenance offices as well. These would be permanent, and then there are always associated with these camps and the permanent operations maintenance offices. There would be wastewater treatment plants or wastewater treatment plant to handle the wastewater produced, and then there would be potable water storage or drinking water storage tanks as well. And then finally, temporarily, there would be storage and laydown yards. These are typically associated with the construction camps, and they're used for storing equipment and materials. So now we're going to move on to talk a bit about geology and geochemistry, and
Excellent.
we'll start. Yeah, this interesting topic. So on the geology side, what we found is that there's sort of 2 different areas, 2 different types of,
Hmm.
I guess, subsurface in terms of generally speaking. So in the western portion, the portion that doesn't sit within the James Bay lowlands, so it's mainly the north-south portion of the road, you get what you call what would you say? What you call undifferentiated till. So till is like what they call unsorted material of different sizes. So when unsorted, that means it's not organized into layers. If you can imagine, Jen, like if you're drilling a hole and you look at the cross section, so as you go down, you don't see them, in exact layers. So that's why they say
A
sort
lot
of
of different stuff.
a lot of different stuff all kind of mixed together, right? And but on the eastern half of the local study area, or the regional study area, which is mainly the portion within the James Bay lowlands. So that's the portion of the road that runs east-west. You're talking about the muskeg areas. So muskeg areas, they're characterized by organic deposits. So that's peat and muck and something called marl, which is a combination of like carbonate minerals with clays and silt. So more fine particles, and but again, it's more the product of decomposition of the plants. Of the plant material, so it's organic deposits. So it's a very different sort of geological environment in the east-west portion than in the north-south portion.
Super interesting place to look at.
Yeah, oh yeah, definitely, and challenging too, Jen. Definitely challenging. So now this next map, it's got a lot of stuff on it. I realize that. We've got a whole bunch of things like we've got. I'll zoom in a bit for my own purposes here. So on this map, we have green stars, and these green stars are where we did the rock sampling, and I'll get into that in a few minutes. And then we have also on this map, we have we have test pits, which are like sort of shallow holes that are typically dug by shovel.
Hmm.
Um, we have what you call peat probes, which is where we stick like a it's kind of like I guess a small tube, jam a small tube into the ground to see the thickness of the peat. So we'll do that,
Yep.
which is important, right? Because the thickness of the peat helps us determine how to design the road and what to consider. So it allows us to sort of get that sort of higher level of detail, I suppose, when it comes to design, right? So when you're working in half a meter of peat, it's different than when you're working in 5 meters of peat. So that's sort of another one of the reasons why we do all this sampling is we have to know what we're dealing with, right? And then we also on this map we show some uh, groundwater monitoring wells that we've talked about groundwater before.
Yep.
We've done boreholes drilling for, and these are done both along the road and in the areas where the potential aggregate pits and quarries will be. So this map has lots of information on it. Let's put it that way. That's the best way to describe it.
Yes.
Yeah, I don't want to overwhelm people, but there's a lot of information, and it sort of represents a lot of work that we've done over the last few years as part of the geology side of this project. Let's now move and talk a little bit about geochemistry. And when we talk about geochemistry, we're talking about um, the chemistry of the rocks, basically.
Hmm.
So we did some geochemical field work in 2020. So what we did is we did soil sampling, we did rock sampling, and you might ask, well, why do you do rock sampling? Well, we do the rock sampling because when you disturb rocks like this, whether it's by blasting or whatever, sometimes, depending on the nature of the rock, you can get the release of the chemicals that sit within the rock. So we have to find out when we know we're going to disturb this rock in the process of constructing the road. So we need to understand if the rock is disturbed, could anything bad happen? For example, could chemicals that are in the rock be released and get into the water and into the soil and cause, for example, impacts to aquatic habitat, things like that, right?
Right.
This is something that.
And and
Sorry,
probably
Jen.
have to understand how the rock behaves because we'll have to have a
Yes.
plan for some areas about blasting, and you have to carefully blast in some areas because they would split certain kinds of ways, right?
Yeah, yeah, no, that's true too. Like I guess a structural understanding of it too, right?
Hmm.
Like an understanding, what kind of rock is it, and once you know that, I think you have a pretty good idea of how it will behave. But you're right, they need to know that for blasting purposes as well too. So, and we all know when you're building a road, and quite often you have to blast through rock in order to keep, and then you get these exposed rock faces, right? And then you get the rock sort of, and then over time, sometimes you see the rocks erode and end up at the bottom of the slope beside the road. Well,
Mhm.
that's why you do this geochemistry testing, right? Is to understand that if that happens, and are chemicals going to be released? Is acid going to be released into the water and cause other impacts? So we do these tests for that reason, and we do these things called acid-based accounting tests, and we do them to help give us an idea of the characteristics of the rock and its tendency to generate acid. From when it's mixed with water, when it's exposed to
Mhm.
water and it's exposed to air. So we test for things like pH, which is a measure of acidity, sulfur, total sulfur, sulfide sulfur, um, uh, things like that, carbon, inorganic carbon, all with the purpose of ultimately trying to understand how this rock will behave when it's exposed and when it's fractured like this. So we did these tests. So these samples get sent to a lab. Specialized labs do these tests. And then we've got a couple of tables here that I'm going to bring up on the screen. And the first one talks about the bedrock, so the rock that was actually tested. And the second one talks about the soil that was tested. And it looks at the greatest sulfur content that was detected. And so it goes through sort of um, talks, provides some numbers, NPR ratio ranges, but in the end, the actual acid generation potential was considered low for the bedrock and very low for the soil. So that was good news for the project. So we're not, creating another hazard here by by doing this, by disturbing the rock based on this sampling. And then we
Mhm.
did the leachate testing. So leachate is when water comes in contact with the rock that's now been exposed, right, fractured. It's leaching is the release of the chemicals that are in the rock into the water. That's called leaching. So what we're doing with these tests is we're doing the probability of metals in the rock getting into and mixing with the water and then causing other potential impacts by contaminating soils, changing the chemistry of the soil, changing the chemistry of the water, whether it's in the lakes and rivers and streams. So the good thing is, again, is that the probability of this happening for the bedrock was low and for the soil was sort of a medium probability. So that was pretty positive news, Jen. But these are tests that typically have to be done for projects of this nature, but fortunately, it looks like the results were pretty good. Now that will be monitored
Mhm.
during the course of the project as well, too, right? While construction's going on, there will be further testing just to make sure that those results are that what we're seeing is consistent with the results that we got from our field work, our baseline work. Let's now move and talk a bit about geological hazards. So you might be asking, what the heck is a geological hazard? Well, there's a whole bunch of
Yeah.
different kinds of them. Yeah, there's lots. There's pretty bad case scenario like an earthquake.
Okay.
Unfortunately, those aren't particularly common in this area that we're talking about. Slopes, so people can understand that. Landslides, right?
Mhm.
Again, fortunately, we don't have major steep slopes in this area. So the chance of landslides is pretty low because the slopes are pretty low.
Yeah.
Sinkholes, there's no real chances of, not a lot of possibility of sinkholes developing. And then we have things like what you call isostatic rise or subsidence. And that's just sort of one is the reverse of the other, right? So it's like swelling or heaving of the soil or of the subsurface.
Mhm.
and from various reasons, subsidence is failing, right? So it's like sinking. So even a sinkhole is kind of like an example of subsidence, I suppose. Um, so the good thing is, again, more good news. There aren't any major hazardous slopes within the area, as I mentioned. So no landslide hazards, no sinkholes, no major geological depressions or strange, what they call geological anomalies or strange things happening or different things happening. So no surprises there, which is good. Um, and then, so in terms of, let's move now to talk a little bit about soil erosion. So we all know what erosion is.
Mhm.
It's the release of soil particles, right, from the earth. And it can be caused by wind, it can be caused by rain, it can be caused by just
All of
weather
the
conditions,
elements.
all of the elements. Yes, thank you. Extreme weather conditions. And this is a natural process. It occurs over time, but you know, when you interfere with things, it can accelerate. So for example, if you
Mhm.
are building a bridge across a river and you are not taking proper precautions, which you should, because you should have an environmental management plan in place to make sure that you're not causing, undue hazards in terms of soil and erosion. But if you don't take those precautions, that can cause accelerated erosion because you're exposing what were vegetated slopes where the bridge is going, and a lot of that soil could get released into the watercourse and temporarily or sometimes permanently change the environment, right? Change the aquatic environment, which can impact
Mhm.
aquatic life, right? From the right from the bottom, and with our friends, the benthic invertebrates, all the way up to fish. Do you notice how I worked in benthic invertebrates there?
Yeah, I
I
like
knew I could
that,
get it
Don.
in
That
there.
was pretty quick.
I figured I had to get it in there somehow, Jen. So anyway, we did some. We looked at the soils that are in the study area, and we looked at their erodibility. And there's a factor called the K factor, which indicates erodibility, and with like something like sand being a K factor of 0.02, like regular coarse sand, the thicker, the larger
Mhm.
particles, and then very fine sand is very erodible, right? As we know, like on a windy day, if you're at a beach with fine sand, sand's blowing around like crazy, right? Because it's small, they're fine particles, they're very light, the wind can toss them around.
Well, I
So a K,
and I noticed
sorry,
when we were in Webequie on a windy day, the it was like dust flying around, right, when it's really
yeah.
windy. So there's a lot of that in that area as well. So
So
a
that's the
finer
fine sand,
sand. Mhm.
yeah, or silt or whatever, right? Because
Mhm.
although silt is now what we found mainly in the study area is silty, sandy silt. So it's like a mix, right? So it sort of has
Mhm.
characteristics of both. So it's sort of in the middle ground. But yeah, when you get the really fine materials, they can get tossed around, blown around, or moved around by water pretty easily. Um, so in terms of erodibility, the soils are sort of in the mid range in terms of K factors, but of course with higher flow velocities. So if you have increased flow in through water courses, that increases erosion because you've got more water, and if you've got exposed slopes along the edge of a water course, they're not vegetated, then that soil is then more easily dislodged, and then it gets into the water
Mhm.
course, and good things don't happen after that. So that's why when you build these watercourse structures, there has to be a lot of really um, thorough
Solid
measures in place.
plans.
Yeah, solid plans that are actually enforced by inspectors to make sure that what's in the plan is being done so that you're not releasing all this soil into the watercourses. So, very important. Now, let's move next to another big topic called physiography. Great name, physiography.
Physiography. Physiography.
So
Physiography.
physiography is physical geography, right? So let's
All
say
right.
I'm and again I'm doing this off the top of my head, but it's sort of like the physical geography is like the shape and describing the land, the physical characteristics of the land. So they divide the country into a number of different what you call physiographic regions. So
Mhm.
they're almost like classifications, right? Unique sort of areas that all have the same characteristics, land and water characteristics. So, of course, as we probably know, this site sits within the Canadian Shield in an area called the James region.
Mhm.
And this is the Canadian Shield, the James region extends from the center of Manitoba all the way to Labrador. So it's a big, big region.
Very big.
And yes, so that's part of the study area. And then another part of the study area sits in the Hudson Bay lowlands, which is sort of a depression. If you can imagine the Canadian Shield and then this lower portion, sort of like so lower elevation below the Canadian Shield, and it's kind
Like a
of
shallow
swampy and
bowl.
it's a shallow bowl, that's right. And the water is sort of sitting there. It's moving. It is actually moving. It does have a direction. You may not think it is moving, but it does. And so and it's swampy and low. And as you get closer to the coast, quite often you see what you call raised beaches on the Hudson Bay coast, James Bay coast as well. And when you go up to the coastal communities as you approach by air, you see these sort of ridges, sand ridges, as you approach the actual shoreline, and it's really interesting. So that's another characteristic of the Hudson Bay lowlands. So yeah, pretty cool environment, Jen, I would say. No
Mm,
question about
I
it.
would say. Mhm.
Challenging too, right, to build roads in, but um, let's move now to talk about soils. And so when we talk about soils, so when we talk about the subsurface, we like to talk about, we use a word called stratigraphy. And another big word, but
Stratigraphy.
stratigraphy is if you can imagine, that's basically showing the layers as you go deeper, right? That's what the stratigraphy is. So if you drill a hole in the ground and then you look at the sides of the hole and you look at the
Mhm.
different layers, that's the stratigraphy of the soil or of the subsurface. And so, in our project area, we get a bit of everything, right? Depending on
Mhm.
where you are. So in that lowland area, the stratigraphy is a lot of organic soils, right? And then with peat as well too, like organic layers, peat layers, organic silt, and then as you move into the higher and drier areas, as you move west along the road and start to turn north, you're getting into
Mhm.
those tills, right? Those layered tills and
Mixed.
non-layered tills, we get a mix, right? You get a mix of different soil particles. So anyway, very different, two quite different areas in terms of soils. And those organic soil layers that sit within the muskeg areas and the east-west portion of the road, they come from decaying plants. That's how they're formed. They decay over time, and then they form these organic layers. The peat layers are through again much of the east-west portion of the road, and we've done various studies, and we've identified that the peat ranges in thickness in through the lowland area between zero point 0.5 and 5 meters. So it gets quite thick. So lots of challenges there when it comes to soils. And now let's move to permafrost. Now, permafrost is, I'll say, not as big a deal as it is in Arctic areas.
Mhm.
Permafrost is, we are actually in what you call a discontinuous permafrost region. So what that means is it's here and there, um, and it's not really in a lot of different places. It's very isolated. And I know I've heard from community members, just from over the years, occasionally they encounter it in certain spots or certain characteristics. I mean, technically, it's defined as any type of ground that is frozen. for 2 or more years at a time. So it's not a huge issue for us on the WSR project. Um, but again, it's something to be aware of
Mhm.
because it is discontinuous. So you never know, right? It might be here and there. But again, that's why you do the sampling. That's why you try your best to understand what you're dealing with when it comes to prior to design and construction of the road. So
That's it.
yeah,
Even
lots.
houses, Don, I just have to say that. I've been way up
Yes.
north, and I noticed
Yep.
that they build houses above ground and there's no basements because of the permafrost.
You got it. That's right. Yeah,
Mhm.
because you don't want to start cracking that open. But now what's happening?
No.
No, but what's happening now in the Arctic is right. You're getting this melting of the permafrost, so you're getting these areas like in this photo that you see on the slide.
Pockets. Mhm.
Yeah, it's a pocket where it's collapsed, right? There's been subsidence and it's just sort of sunken there, and that's a little scary. With another scary uh, more scary evidence of climate change, I guess is the best way to describe it. I would say,
Mhm. And that's why
wouldn't
we're
you?
looking at that geotextile type of road, right? So it's going
Yeah,
over top
that's
because
part
we
of
have
it.
to keep
Yeah,
in mind so
absolutely.
many different things. We've heard about the very mixed terrain with different kinds of soil, different kinds of rock, and then muskeg and peat, and then permafrost as well that we have to be aware of.
Lots of stuff to consider, right, in building the road, right,
Hmm.
Jen? Like it's not straightforward. This is not there's a certain amount of unpredictability to it, right? So you really got to do your
Hmm.
homework before you go out there and start building. But wow, we have run out of time, Jen.
It's time.
Wow. Yeah. Wow. That was a lot to cover. Well, that wraps up today's geology, terrain, and soils preliminary findings. We hope this was helpful and encourages you to join us again. Don't forget to keep in touch with us. So our project team members via the contact information available on our website, supplyroad.ca. Miigwech, and we will see you again soon. Thanks, Jen.
Oh, bumblebee.